All right, so the completing the square is actually another tool instead of factoring. When things aren't factorable, we can complete the square in order to find the roots of the function. So we'll show you how to do that, and then we'll talk about how the quadratic formula was developed through this process, and I'll actually show you a proof of how the quadratic formula came to be. All right, so just know that over the past few weeks we've been learning a lot of stuff. Stick with it. Review some of the past week's lessons as you need, and attend the Zoom meetings or email me if you have questions. I don't expect you to master all of this. I do expect you to watch the videos and to do your best, so please keep that in mind. All right, so this is an example of something that comes in vertex form, or completing the square after someone completed the square. And so I want to show you how to use this to solve an equation. So everything is in balanced moves, just like it was in Algebra 1. In order to do this, we've got to undo PEMDAS, and I think about doing PEMDAS backwards, which means instead of doing parentheses, exponents, multiplication, division, addition, subtraction, we're actually going to do this process backwards. So we're going to undo subtraction, then undo multiplication and division, and then undo exponents and so on. So in order to do that, I have a subtraction sign. So I'm going to undo the subtraction. So I'm going to add 8 to both sides. And now we've got 2 times x plus 1 quantity squared equals 8. And then I move backwards, so there's no more addition and subtraction to undo, so I have to undo the multiplication and division. I'm going to divide both sides by 2. Divide by 2, those cancel out. Divide by 2. So I get x plus 1 quantity squared equals 8 divided by 2 is 4. And then, how do I undo a square? Well, I undo a square by taking a square root. So I have to take the square root of both sides, so that leaves me with x plus 1, because it undoes the square part, and then the square root of 4 is 2, and it actually leaves me with plus or minus 2, and that's because if I reversed this in the backwards order, I'd have to 2 squared is 4, but negative 2 squared is also positive 4, so you have to consider both of those options. And then I'm going to subtract 1 from both sides, but remember, this is a plus or minus, so this is x equals negative 1 plus or minus 2, which means, really, it's negative 1 plus 2 and negative 1 minus 2. So really, that's 1 and negative 3. So x equals 1 and x equals negative 3. So that's how we can use something in factored form, vertex form, to solve for the roots. These are the roots of the equation at 1 and negative 3. At 1 and negative 3. So that's what those are, so that we could go ahead and graph this thing. Now I want to take a look a little bit, remind you how to complete the square. Remember, we're taking that b term, which is the middle term. In this case, it's negative 7. We're going to cut it in half. So divide both sides by 2, so negative 3.5, and then we've got to take it and we've got to raise that information to the second power. So negative 3.5, negative 3.5 times negative 3.5 is 12.25, and it's positive because it's it's 2 times the negative, so I'm negative, and we've got x squared minus 7x. And then we're going to move the negative 44 over, and then we're going to leave some space equals 0. And remember, we've got to add in 12.25, and we have to subtract 12.25. In this case, this first part is the perfect square stuff, so it's going to be x minus 3.5. We got that minus 3.5 because it's actually half of b. It will always be that way. So all of that stuff squared, because that's the perfect square part. And then negative 44 minus 12.25 is negative 56.25 equals 0. Now, we're going to solve, and we're going to do it the same way we did before. We have to undo this subtraction, so we have to add 56.25, add 56.25, And so we've got x minus 3.5 quantity squared equals 56.25. And then we've got to take the square root of both sides, and we're left with a plus or minus. So we get x minus 3.5 equals positive and negative, this square root thing. And I'm going to put it into a calculator so that I get a decimal form, but it's going to be a long decimal. Well, actually, it doesn't turn out to be that bad. It ends up being 7.5, which is handy, because then we don't have to do a ton of extra work. And our last step is to solve for x. So we're going to add 3.5, add 3.5, x equals 3.5 plus or minus 7.5. So remember, there's two answers here. There's the positive version. X is going to be 3.5 plus 7.5. And x is also going to be 3.5 minus 7.5. So 3.5 plus 7.5 is, and I'm just making sure in a calculator, 11. And 3.5 minus 7.5 is negative 4, I think. 3.5 minus 7.5, yeah, negative 4. And remember, those are our roots. So one of our roots is going to be here at negative 4. The other one's going to be all the way out here at positive 11. That's what these numbers mean because it was a set equal to 0. Okay, so completing the square and solving isn't quite as bad. It's not quite as easy as factoring, because factoring is kind of nice, but it can be a very efficient method. And in fact, this procedure, if there are roots, will always work. What we love about this is that it always has an answer, or you can find some version of an answer using this process, whereas factoring, you only can do it if something can be factored. It doesn't always work. All right, so how do we do this? How do we do this completing the square thing when the number in front isn't 1, right? Because normally it's just x. But how do I do it if it's not 1? Well, in order to complete the square, it has to be 1. So the easiest, quickest thing to do is to divide both sides evenly. You can do this in an equation because you can do it evenly on both sides. Divide everything on both sides by 3. Well, because it's balanced. This is totally legal and possible to do because I'm doing it fairly to everything on both sides. So I've got x squared, and then minus 2x, and then negative 45 divided by 3 is negative 15, and then 0 divided by 3 is 0. Well, now I can just complete the square because my b is negative 2, half of that is negative 1, and half of that squared is positive 1. So I've got x squared minus 2x minus 15 equals 0, but I'm going to add 1 and I'm going to subtract 1. This is my perfect square, so x minus 1 quantity squared. I've got my leftovers here, so minus 16 equals 0. Oh, hey, wait, the vertex is right there. The vertex of this equation, if you were curious, is, well, almost. Well, we forgot to get the 3 out of there. It's 3 as many of this, but I'll save that for another video. And then to solve, we're just going to undo pieces of this. We'll add 16 to both sides. So x minus 1 quantity squared equals 16. Square root both sides. So x minus 1 equals positive and negative. Remember, positive and negative because I don't know if it's going to be 4 or negative 4. Square root of 16 is 4. And then finish it up by adding 1. And we get our two answers. X equals 1 plus or minus 4, which is really 1 plus 4 and 1 minus 4, so 5 and negative 3. And one more time, at that negative 3 and 5, negative 3 is one of our roots, and 5 is going to be one of our roots. So I hope this is all kind of coming together in terms of how this all works. But that originally, that 3 can be eliminated, and this is important. because I'm about to show you how to generalize this process. So if I were to complete this square, instead of having numbers here, instead of 2, 4, and 6 or whatever, I use placeholder variables. And A just represents any number, B represents any number, and C represents any number. And I'm going to complete the square and then solve for x. Now this process is going to get very messy really, really quickly. It's going to be very long. Don't worry if you don't understand it. Try and follow along. My expectation is you watch as best you can. So remember, we were dividing both sides by the a value. We got to do that, but it's not going to be as nice as the last time because everything is going to kind of come out a little bit clean. Not quite as clean. So these actually cancel out and we get x squared. But this ends up being the fraction b over a x. And this ends up being the fraction c over a. And they're just numbers. And 0 divided by a is 0. But each of these pieces, this is just a number, and this is just a number. All right, and then we were going to complete the square. So I think about my b value. The b value here is this, right in the middle. So our b value is b over a. Half of that is b over 2a. And the reason is because when I divide by 2, it combines with that. And then if I square it, b over 2, half of that middle term squared, it's going to be b over 2a quantity squared. And really, we can use our exponent rules to say this is really b squared over 4a squared. Okay? So we're going to add that back in and subtract it out again. So we've got x squared plus b over ax. These are just coming down from here. And then we're going to leave some space. Plus c over a. Leave some space equals 0. And we're going to add in b squared over 4a squared. And we're going to subtract b squared over 4a squared. And remember, this stuff right up front, it's going to come out really nice. It's going to be that x minus b over 2a from here, right? It's that middle term cut in half is going to be what we get. All of that squared. Oops, sorry, that should be a plus. And then this is going to be kind of nasty for a little bit. It's going to come together, and it's still positive c over a, and it's still b squared over 4a squared. And it's all equal to 0. I'm going to move this up, but I hope you're following along. Well, now, I want you to just pay attention. X is a variable, and everything else here, everything else is just a number that is being place-held by letters. So we're going to solve this, which means that we got to subtract c over a on both sides, and we're going to subtract, we're going to add b squared over 4a squared to both sides. B squared over 4a squared to both sides. And I'm kind of lumping these together, but it's a balanced move because it's happening on both sides of the equal sign. So I'm left with this x plus b over 2a, all of this stuff squared. It's going to equal, negative c over a plus b squared over 4a squared. That's a little weird, right? In fact, I'm going to actually, I'm going to move this just so that it, I'm going to move this so that it comes over here. So it's minus c over a. And that's going to help us out in just a few minutes when we're doing some stuff. Well, I don't like the fact that I have two fractions here. I don't like that. So here's what I'm going to do. I'm going to do kind of a sneaky move, a very sneaky move. And I'm going to multiply by a really strategic fraction. I'm going to multiply by 4a. And the reason I'm multiplying by 4a is that this denominator here, a times 4 times a, is 4a squared. And now we've got a common denominator. So I'm going to just leave this stuff. X plus b over 2a squared is going to equal b squared over 4a squared minus c times 4a all over 4a squared. And I'm going to take it a little bit further. And with the denominators are the same, just going to combine. I'm going to combine like terms. So b squared minus, and I'm going to reorient this. I'm just going to move the 4 in front. So 4 and I'm times a times c all over 4a squared. And that's going to be equal to our regular x plus b over 2a squared. Now, I know this is getting a little bit into the weeds of the solving, but this is a generic formula, generic format where we don't know what the values are yet. And the same thing, we're going to square root both sides. We're going to square root this side, we're going to square root this side, and over here we're left with x minus b over 2a. Oh, I'm going to do that. I should do that in black. We got x plus b over 2a equals the square root of the top and the square root of 4a squared. Oh, this is handy. This is nice because the square root of 4, this actually transitions. The square root of 4 is 2, and the square root of a squared is 2a. And I like that because this has a base of 2a, and this is going to have a denominator of 2a. I'll go ahead and move this up. Did not let me move it. I didn't want that. Okay, so I now have x, here I'll write this out. I now have x plus b over 2a equals the square root of b squared minus 4ac. All of that over 2a. Well, I got to get x all by itself, so I got to do some subtraction. Minus b over 2a minus b over 2a. And what do you know? We get x equals negative b over 2a plus, wait, what did I forget? When I took the square root, I needed a plus or minus. I needed a plus or minus. I needed a plus or minus this stuff. B squared minus 4ac, that over 2a. Hey, common denominator, we can add or subtract them together. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all of that over a common denominator of 2a. This, my friends, is the quadratic formula. And I know it took a long time to get here. In fact, it took us 8 minutes to get from the very beginning to here. But I want you to see that all this process is the generalization. I divided by a. I took the middle term, I completed the square. I'm solving for x. I'm doing a lot of this algebra, and I'm throwing it all together. So, thank you for watching. I know this went really quickly. I'm going to glance through. I'm going to show you the typed up version. Pause the video if you want to view it. But this is the generalized version. It is how the quadratic formula came to be, and it always, always, always works.